Any other different place traits? So this is your screen, presenter screen. That is actually screen. So if you want to note down anything or time में यहाँ पर अच्छा करेगा. अच्छा.
सर्वर नहीं जाना करता. अच्छा तो प्ले करावा लगेगा.
हाँ सर play.
नेक्स्ट का एसेस ना.
हाँ. हाँ.
Okay.
Good. So anything but I am.
Hello. Hello. Should we start? Should we be ready? So we'll be talking about wireless microcontroller programming today. So how many of you have already worked on microcontrollers before? Any microcontroller? So almost all of you. Who haven't worked? Few of you. So we'll give a few slides on how programming on a microcontroller is different than what to do on your PCs or laptops or for the cloud. So how you think differently for that. Then we'll talk about features of the boards which use microcontrollers. So it will help you to next during the hackathon. So when you decide, like you have some idea in your mind and you have to implement it, something like maybe a remote vehicle or smart controller. So you have to decide whether you will be using a powerful microcontroller or microprocessor. So how do you decide? So if you want your device to be battery operated, then there is a high probability that you will have to use a microcontroller because the power consumption is quite different for both of them. And the cost wise also it is quite cheaper. So if you purchase in bulk microcontrollers, you can get in few cents, like 50 cents or $1. So typically, when you write any Linux application or a Windows application, you don't care about any other processes because if you do something wrong, the OS will kill your process, and you can be sure that no other process is harmed. So on the microcontroller, it doesn't work that way. So the entire address space, whatever it is under your control. So if you cause any buffer corruptions while programming, then you will also affect other processes. And the bad part is that it is very difficult to debug because you don't know what has happened. So the nowadays, due to better debuggers, you can find out like using breakpoints or watchpoints. It is easier, but not all tools have those. Like those tools are quite expensive. So while programming, you have to be very careful. So even the operating system, like the OS which you'll be using, even the OS internal data structures are open in RAM. So if you go and corrupt them, then it's very difficult to debug. So almost like all the microcontrollers available today. So most of them have flat address space. So there is no concept of MMU, logical, physical, nothing. Just a single, simple address space. And when you're programming on a Linux, what happens is that you have a OS running and you load your program into it, you just run it. So your it works a bit differently. So when you compile your program, the entire your program operating system and all the libraries they together form a monolithic binary, a .bin file or a firmware image if you will. So you just flash it and run it. So if you change anything, you have to go to the entire process of building the OS and then loading it again. So one interesting part of working with microcontrollers is that you have access to the entire source code base most of the time, especially when you work with open source operating systems like FreeRTOS. So what happens is like typically like when we work day to day, if we find an issue, we can go and go inside the OS and do some things to debug it. So let's say that I'm having problem with implementing a protocol, let's say MQTT or something, and I observe that there is some packet problem or some corruption. So I can go below and actually dump packets at the lowest level. It is easier to debug. So how many of you have worked in Linux, embedded Linux? And so, when you work with Linux, typically you may be writing a device driver or some application. So, when you work on the system part of it, so you have to deal with quite a lot of abstractions like having a device level files, major number, minor number stuff, virtual file systems. So all of that is not present here. So let's say that you want to go and change the GPI or turn on or off some LEDs. You just go and set the GPI to 1 or 0. It's very simple. If you want to interface with some I2C device like SRAM or temperature sensor, you can directly work with the device level APIs. And on a Linux machine, typically you have to go through the abstractions like character device driver or a block device driver. So here it is, you directly access the API. So the downside is that you have to know how you use the API. So you have to understand how it works. So people who work on microprocessors, they can assume that they have a lot of memory. So the memory in microcontroller devices is quite small. So this 512 kilobytes of memory is available, SRAM. That is the only SRAM is available. So, but like I'm working on this like last for 5 to 6 years. So you can implement a lot of stuff in 512 kilobytes. But you have to be very careful when allocating memory. So you have to ensure that you use less memory and you cannot give that kind of flexibility. So this is one of the boards which, one of the chips which we use. So for programming a hackathon, there is a hackathon. This we have two boards available. One of them is this NIT board, which has this CPU, and these are the features. I have a slide on it for later. And this is Amazon AWS board. So this is a bit more powerful board. The CPU is same, but you have more GPUs and better chips. So we'll talk about it later. This is typical, so you can interface many external components to it. So you may use this to interface many external chips for your hackathon. So the device levels are ready for this. You just have to interface a chip and write small programs to talk with them. This chip also has a DSP and FT support. So if your program or if your application requires that, then you have it. You have available. Yeah. So this is the main board. So the cost of this board is around 1,000 rupees. So it is cheaper. So you can build your application around that. So it has very few external components. This is the main wireless microcontroller module. So the idea of a module is that whenever you build your application or your board based on any wireless device like Wi-Fi device, so to get it productized or sell it in market, you have to first get it certified from uh, governments or competent authorities like European Union and FCC. So the advantage of using this wireless module is that you don't have to do all of that. This comes certified with all uh, those points. You can just interface this module on your board and whatever components you require, and this board is ready. So on this board you have a debug interface for MP flash. So the microcontroller doesn't have any internal flash. So all your programs will reside here. This is the module, and you have a serial to USB converter. So you can have your console using that. So you can connect your serial terminal on your PC to this board to have debug console. Just information about it. So this slide will be available online, so you can have a look later. Okay, the software is open for this board. So I just take a break. Anybody has any questions or specific queries which you have on this? Okay, so power supply using both of them. Yeah, you can connect a battery to that. Wi-Fi stack. This board comes with an SDK, so it has Wi-Fi inbuilt on it. The stack is there. So we have a networking stack, TCP/IP stack, Wi-Fi driver. So I'll show a snippet later. So it is very easy to communicate or be online, get online using this board. I'll show an example. So GCC is supported. GCC based So this is the interesting part. So when you get this board or any wireless microcontroller board as such, what you get is a feature or a platform where you can directly connect to the internet using normal socket programming. So it becomes very easier for you to interface your board with the internet. So build IoT based applications on it. So you don't have to do all the low-level stuff of managing internet connectivity or TCP/IP stack. So all of it is ready.
Can you program with any language?
For you can program with C and C++. Most of the others, the problem with the other languages is especially high level Java, and they take a lot of memory. So you can't fit all of that in 500 kilobytes. So that is the main problem. Because one example I'll give you, we are writing an application and our customer provided us a code written in C++. So the footprint of it was going up to 700K flash, not RAM, 700 kilobytes. So we asked them to optimize it to write it in C. So they rewrote the entire thing in C, and that code fit in about 250 kilobytes. So it is, and the same functionality. So that is the problem with high-level languages. Even if you don't use things like templates and exceptions, still the footprint is quite large for those higher level stuff. So that is the problem. So that is why most of the IoT guys still program in C. It's very efficient. So when you start looking at it, like when you started programming for the hackathon, you can assume that you have the entire BSC socket library with you. So you can use connect, bind, everything. All the socket APIs are available. So talk about this. Wireless manager is you just give your SSID and passphrase and it will connect. So that is all that you need to do related to Wi-Fi. Because that is most important part, right? So when you're dumbing your code to somebody else, so you have to first connect it to some wireless access point in your locality. So on a phone it's very simple. You just go to your phone, select your SSID, give the passphrase, and that is all. So on the board it's very difficult because you don't have a screen with you. So that problem is like you have to solve using some methods. So we'll talk about that in the next screen. So these are all the sources of total stack that is available. So we have three of those available about TLS. So most of the so this is an important part. So when you want to interface with any cloud server, like let's say Amazon Web Services or Google Maps API, so you have to use TLS. So you have a security library support in the SDK for that. So you can just connect directly. You just give your certificate for the cloud and you can start working with it. This is a very simple program. So typically on your Linux machine, when you write this program, you assume that when you enter main, when your first line after main starts executing, your PC is booted up and everything is working fine. So here the things are a bit different. When you boot your microcontroller, default main is called. You have to initialize all the devices like the operating system and your device drivers. So all that happens before that. So all of that is in your control. Typically, the SDK gives you templates for that. Right. So this is the part where you take help of the SDK. There's an API called wlan start. You just see your there are two ways here. If you already know the XSID passphrase, you can just give that here. Or the second way is you have to do provisioning. So what is provisioning exactly? So when you buy any device which connects to the Wi-Fi, your smart TV or any other Wi-Fi device, so first you have to connect it to your access point in your home. So that is the Wi-Fi provisioning process. So how it works on this microcontroller is you start an access point on this board itself. So when you boot this board the first time and when you call this API, it starts an access point. The board becomes an access point. Then you connect your mobile to the board. The board sends out beacons. You connect it to that SSID and you send the SSID passphrase of your home router through a web interface. Then that gets stored inside this internal storage module. And when you reboot the board again, it will connect to your access point, home access point. And then your main programming starts where you communicate with the external world. This is the provisioning process. So, anybody has done Android programming? So you know how it works. Like you register your class with the framework, and then you get callbacks based on certain various events happening, like in the system, wlan disconnection connection. So same thing is here. You have this callback, you register all these callbacks, and then you get various events. So you have to manage them. So whenever your board boots the first time, it will spend a few seconds connecting to your access point. and later when the connection is complete, you will get a call back, and then you actually do your code implementation starting from this point after the wlan is connected. Sanjeev, just working with VPIs. Okay, so it's a very short presentation, so I think anybody has any questions? Yeah, Wi-Fi provisioning. Okay. So what happens is when you call the API, you tell it the SSID and the passphrase. So that API internally starts an access point, and it also starts a web server on the device. And you connect to that SSID, give the passphrase, and you go to your browser and give the IP address of the board, and a web page opens up. Then you can specify that. It will show a list of all the access points in the locality. So you select an access point, and that will be configured inside the board. Passphrase of the SSID. Which password? So you access the web browser, sorry, web server running on the board. So the page opens up, the configuration page. The configuration page shows a list of all the SSIDs in the vicinity, all the access points. So you manually select one of them. It will ask you the passphrase of that particular access point, and then you say set. So when you submit, the SSID and the passphrase which you entered is stored on the internal storage of the board. And from that point on, then the board can start connecting to the access point, which you specify. Yeah, it's specific to your product. Yeah, correct. So when you buy new access point, typically you have an SSID passphrase written as a address similar. So when you sell your product, your product box will actually have the SSID name and the passphrase. So the same you have to enter in your code program. Yeah, you can. You can. But you have to handle the part where which one to get up. So that is an app specific part. Because you have to decide like which one to give priority to. But what you can do is you can get signal strength of the access point. There's an API for that. So you can decide which API is closer and then select one. Yeah, that is possible. So, but the application part has to handle the selection of priority among them. But you can have them configured. The SDK supports. So your questions, you can ask me questions related to like you're planning to use a microcontroller, any not just this board, any board, and you have some questions on how to make it work, how to use that in your application. Especially questions related to working with the internet, basically working with wireless applications. So anybody of you planning to integrate with cloud, AWS, IoT? Right. So, are you aware of the security part of it, the TLS part? Right. So, if you want to verify the credentials of the server, you have to copy the certificate. Yeah, it's a So you have a TLS library called Wolf SSL. So Wolf SSL. So you just have to give your URL and the particular certificate, and it just works. See, no, this already has all of the AWS libraries. AWS and OpenSSL are two different things because you connect to AWS using SSL. So what AWS gives is they specify URLs and the protocol to talk with those URLs. So you have to first connect to that URL using TLS. Uh, Depends. Like if you want your device to be tested or verified by the server, then yes. Otherwise, no. Otherwise, when you will be talking, if you have a product and you are working with a particular cloud provider, like say Amazon, or there's one more called Everything, or you can use Microsoft. So there are many cloud providers. So what you will have is you will have only one certificate of the cloud provider, which will program into your all of your devices, all devices of the product. And then you also have to have the picture of upgrading the certificates after a few years because certificates keep on changing. So that will be part of your firmware upgrade capacity, which you have to build anyway in your product. Is that all done? No questions? So anyway, we are available, so we can talk with them. You want to discuss specifications.